Sometimes you'll be able to look at radicals in terms of their graphs. Looking at the radical in terms of its graph, you can determine whether it's shifted left or right, up or down. Did it reflect over the y-axis? Did it reflect over the x-axis? All of that good kind of stuff is based on our radical function. So a radical function, remember, is in the form of f of x equals a, some type of root, so some number n, x minus h, and then plus k. So notice this is kind of similar to quadratics a little bit, that we're dealing with an a, h, and a k. So the a is going to be your vertical stretch or compression. So this isn't moving it up and down, it's just literally taking it and stretching that sucker. The H is your horizontal translation. So shift left or right. Just as a reminder, this is opposite of what you see. K is your shift up and down. This is going to be straightforward with the plus k. So if we want to look at the graphs a little bit, so I have here the square root of x. This is the parent function. So just talking about, what happens with the h, what happens with the k, what happens if there's a number in front, all of that good stuff. So if you notice here, this one, I have a horizontal shift. It is shifted to the left 3 because it's opposite of what I see. Normally you'd think plus goes to the right, but because it's the horizontal, it's going left 3. So just so you can kind of see that there. This one here is a vertical shift. It's on the outside of that square root, so it went up 3. Now these two are interesting. If the negative is underneath with the root, this is going to reflect over the y-axis. So this might be something you want to put with this. So reflection over y. Now the difference, which you can probably already guess, with the negative out in front of that radical, it's shifted, or it's flipped or reflected over the x-axis. So just a little bit of a difference there. But something to note of where it's located. So looking at all these different things, we're going to kind of look at this and combine some stuff and figure out, how does the graph shift left or right, up or down, all of that good stuff. And then sometimes you'll be given a picture of a graph and you'll have to figure out what is the transformation of that graph. Okay, so let's say that my function is 2, we'll stick with the square root here, x minus 3 plus 4. Okay, so what we're doing here is we're just trying to figure out, okay, what is happening with the graph without having to graph it. 2 is going to stretch it. That 3 there means that I'm going to shift to the right 3. And then that 4 means we're going up 4. So we can now look at our graph, look at the parent function. Oops. So my parent function is that square root of x. Now I'm going to type in the function that I was supposed to describe here. Square root of x minus 3 and then plus 4. So looking at this, we did in fact shift to the right 3 and we shifted up 4. Those are the easy ones to figure out. Now that stretch is a little bit different to kind of look at. So I'm actually going to take away that +4 and that -3 just so you guys can see what actually happened with that 2 compared to that parent function. So if you look here, you can see based on that red graph that stretch, it stretched it vertically. So here's how I like to think of it. I like to think of it as I pick a point here. So on the original function, it's 1, 1. I should do that in blue, because you know that would be the parent function. And then that new function is now at 1, 2. Well, that's interesting. Let's see if there's a connection there. Let's find another point on our parent function. I have a point here at 4, 2. Now look at the new function. This is at 4, 4. So notice here, it's being multiplied by 2. So this 1 here is being multiplied by 2 to get that number. 2 times 2 gives me this 4. So that's telling me how I'm going to stretch that graph. Okay, so just so you can kind of see that a little bit. So since we've looked at it, you know, from the equation and then gone to the graph, let's go the reverse way. So notice I have the equations hidden there, but I'm going to tell you this. The blue here is our parent, and this is the one in red is what we're trying to find. Now, some of you might be thinking, okay, we haven't seen this graph yet, you know, what is it? The parent function is the cube root of x. Okay, so we're going to look at this and kind of determine here and decide how did this move. Okay, so key note here is I always like to pick a few points that I can see on the parent and then try to match those up with the new equation we're trying to find. So I've got a point here at 0, 0. My tick marks are going by a half, just a FYI there. Second point is at 1, 1. I can see that I also have a point here at 8, 2. Okay, so I'm going to pick up some points here on my red graph. So I've got it at 0, 3. I've got a point here at a half, 4. Then I have a point here. Yeah, let's not work with that one. That one's, yeah, it might work. Yeah, it'll work. 4, 5. Okay, so we're going to kind of compare these and figure out what has happened. Okay, so looking at, I always like to start with where the starting point is, whether that's 0, 0 or, you know, it generally will be for a root, it'll be a 0, 0. So looking at that, how I can see that 0, 0 point, or the starting point, kind of where the curve, you know, switches there, it has moved a +3, and it didn't shift left or right here. So looking at this, I have a cube root of x there, and then I've got that +3 on the outside of that radical. So it didn't shift left or right, so I don't need anything underneath that radical there. But we need to look at, we obviously have a little bit of a stretch. So if you look here, 1, 1 and a half 4 are related. Well, if you're looking at this +3, 1 + 3 would get me this 4 here. So there is not a stretch on the y-axis, which means this number on the outside of the radical is a 1. There was no vertical stretch. But now we're going to kind of compare here. There was obviously a stretch, though, in the x's. We went from 1 to a half, and 8 to 4. So what we're doing there is we're cutting that number in half. Now this is going to seem kind of counterintuitive. You're cutting it in half, which means that you're actually going to be multiplying by 2. Like I said, seems kind of counterintuitive, but it's no different than our shifting left and right. You know how it's opposite of what you see? Same concept when you're stretching on the x, or you're stretching that x value instead of that y coordinate. Opposite of what you see. We're cutting it in half, which would be multiplying by half. We'll flip it, we're multiplying by 2. So this is what we have as our final answer. Let's see how we did. Oh, gotta move my stuff because it's in the way. But we can see that we nailed that equation. So just something to think about. I know this is kind of tricky. We'll probably go through another one of these graphing ones in class just to reiterate the concepts.